Imagine a device small enough to sit on a basement shelf, assembled from parts found at any hardware store for less than a restaurant meal. It can keep your home running through a days-long blackout without a single drop of gasoline, without solar panels, and without ever needing a recharge. This sounds like a late-night infomercial claim, but this is a story about overlooked chemistry and a retired electrician with a shed full of odds and ends. Power outages are becoming a routine anxiety for millions. Aging infrastructure and severe weather are putting pressure on grids that were never designed for this. Standard solutions are expensive. You either spend thousands on a noisy gas generator or upwards of $10,000 on a professional lithium battery setup. For most people, neither option is realistic. That is why Dan decided he was done waiting for someone else to solve the problem in his Midwest home. Dan is a practical man. After watching his food spoil through one too many winter blackouts, he knew there had to be a simpler way to generate power. He wasn't looking for a revolution. He started with the humble potato battery, a staple of school science fairs, where zinc and copper produce a current. The principle is simple. A chemical reaction between two metals in a conductive medium generates electricity. Dan just needed to scale it up effectively. He landed on the aluminum air battery. It's a concept that's been in scientific literature for decades, but was rarely used for household power. Aluminum acts as the anode, air provides oxygen at the cathode, and a mild electrolyte solution completes the circuit to release usable electrons. Dan had no commercial interests. He had a recycling bin full of aluminum and carbon rods salvaged from dead flashlight batteries to serve as cathodes. He used a plastic sweater storage container and a simple kitchen supply of salt and baking soda to create the necessary electrolyte solution. The first prototype wasn't elegant. It was a tub with drilled air holes, repurposed aluminum sheets, and carbon rods arranged inside the liquid. When he connected the terminals to an old camp lantern, the bulb lit up. It didn't flicker, it glowed steadily, proving the physics worked perfectly. The refinement process took months of patience. Dan adjusted the spacing of the aluminum sheets to increase surface area and power output. He dialed in the concentration of baking soda to stabilize the pH, ensuring the battery could run for long durations without side reactions. Soon, his basement battery was sustaining a chest freezer and a Wi-Fi router continuously, even when the rest of the neighborhood went dark. When he tallied up the cost of every single component, the total came to just under $22, a fraction of any commercial solution. Dan's story shows that with a bit of ingenuity and basic chemistry, we don't have to be at the mercy of the grid or expensive corporations. It's a reminder that the solutions to our modern problems might be sitting right there in our recycling bins, waiting for someone to take a closer look. Meet Dan. He's not a corporate scientist, but a local handyman who found a way to turn simple scrap into a months-long energy source. This is his aluminum air battery. It's a low-cost DIY solution that challenges everything we're told about the complexity of power. How does it run for months? The secret is in the geometry. Only a tiny fraction of the aluminum reacts with the electrolyte at once. It's more like a steady trickle than a torrent. The aluminum is consumed so gradually that weeks pass before you see any degradation. Maintenance is like caring for a houseplant. Just a periodic top-up of water, and when the sheets are spent, they're replaced for pennies. The spent aluminum converts to a harmless white sludge called aluminum hydroxide, which can actually be used as a soil amendment. Safety is the first question people ask. Unlike lithium-ion, there is no risk of fire or thermal runaway here. It's fundamentally stable. The electrolyte is just salt water and baking soda. The only precaution is a few ventilation holes for tiny amounts of hydrogen. During a local blackout, Dan's house was the only one with lights on. His neighbors were disoriented by how simple the solution was. He demonstrated it at the VFW hall. People saw a plastic tub powering a fan and radio, realizing the science had always been available. Word spread through results. In Florida, it kept CPAPs running during hurricanes. In Montana, it supplemented solar panels through the dark winter. The DIY community began innovating, using zigzag patterns to increase current and testing different water sources to drive costs to zero. By stacking cells together, you create a modular system. 4 or 5 cells can handle your fridge, lights, and internet during a crisis. This isn't magic. It's the result of building with abundant materials instead of paying for retail markups and manufacturing margins. Dan didn't just build a battery, he shared a toolkit of principles. It's an empowering reminder that energy independence is within our reach. Can a simple DIY project change how we think about energy? In garages and basements, a quiet revolution is taking place right now. It started with Dan. In his shed on a blustery March afternoon, he assembled a demonstration of something much larger than just a battery. Using aluminum, the most abundant metal in the Earth's crust, and simple kitchen chemistry, he pointed a solution at a truly difficult problem. At the level of households and small communities, this idea has already scaled, spreading quietly through one person, showing another something that works. These designs have been adapted by people in rural India, off-grid villages in Africa, and mountain communities in South America. In these contexts, where grid reliability is fragile and commercial costs are absolute, the aluminum air battery isn't a curiosity. It is infrastructure. So why isn't it everywhere? Industry is built on selling expensive solutions, rarely advertised cheap ones. It is the ordinary operation of commercial incentive. There's no proprietary component to sell, no recurring subscription, and the core patents for this approach expired long ago. You cannot make the aluminum scarce. You cannot charge a licensing fee for chemistry that is taught in 10th grade classrooms across the world. This technology bridges a gap, not in knowledge, but in direction. It's about who asks the question and who profits from the solution. The next iteration is already happening in school labs and online forums, with improvements to electrolyte formulas and electrogeometries. New hybrid designs pair these cells with small solar panels for continuous recharge, creating modular systems for apartment buildings and community centers. None of this is waiting for regulatory approval or venture capital. It is simply spreading as practical knowledge from one person to the next. The big providers will keep selling what they sell, but for many, the next blackout will find a plastic tub in the basement humming quietly. It keeps the freezer running and the lights on, assembled for a cost that amounts to a minor afterthought. Not a revolution exactly, but in the long run, this kind of quiet, stubborn self-reliance tends to matter more than revolutions. It is the power of an idea that works. Energy independence isn't a boardroom buzzword. It's a necessity for those facing ice storms in the Midwest who need to keep food safe. For families in Florida, it means staying calm during hurricane warnings, knowing they no longer need to panic buy gasoline for backup generators. In the mountains of Montana, homesteaders use it to bridge the gap when solar panels fail to produce enough power during cloudy January days. The tool that changed their lives costs only $22 and fits inside a simple plastic storage container. This is the aluminum air battery. It's a low-cost DIY energy solution that solves practical problems with everyday materials. Why hasn't this tech gone mainstream? Because a battery made from scrap soda cans and kitchen salt offers no profit margin for corporations. There are no software subscriptions or proprietary parts to replace. Its lack of business value is exactly what makes it valuable to people. Simple solutions like this often hide in scientific literature and old engineering textbooks, waiting for someone with the stubbornness to look. What started as a curiosity became a global community. Engineers, teenagers, and farmers now share results and modifications through an informal network. Retired engineers refine the chemistry and electrogeometry, while teenagers find ways to improvise with even smaller, simpler containers. For those in parts of the world where the grid is a distant dream, charging a phone with salt water is a material improvement. The chemistry is incredibly robust. Roofing scraps, old cookware, and industrial offcuts all work as fuel sources. Even the electrolyte is flexible. Seawater, rainwater, or any conductive solution can keep the system running. A major development is pairing these cells with small solar panels, creating hybrid systems that address the battery's primary limitation. The aluminum air stack serves as a deep backup reserve, called upon only when the solar-charged batteries are depleted. This setup costs just a fraction of commercial installations, allowing families to survive entire winters without grid dependency for essential loads. Dan's battery isn't just about chemistry. It's about providing power and peace of mind to anyone with a few simple tools. It began in a small workshop with a single plastic tub. Dan, a retired electrician, proved that aluminum and water could create power. But the true potential wasn't just in one tub. It was in the community's vision of scaling this into something much larger. Groups in maker labs and community centers began to ask, what if we built a bank of 100 tubs? The physics was simple. More tubs meant more current. The real challenge was organizational. How do we manage a shared resource together? In rural Appalachia, the community center put this to the test. They installed 30 tubs to provide backup during winter storms. When the grid went down for days, the lights stayed on. People gathered here to charge devices and stay warm. The total material cost was under $700. No expensive contractors, just volunteers and basic knowledge of chemistry. Word spread globally. In places where the grid is non-existent, this technology isn't just a backup, it's a lifeline for survival. From sub-Saharan Africa to Southeast Asia, humanitarian workers saw a power source that used locally available materials. The aluminum air battery offers independence. Once you understand the system, you're no longer tied to unreliable external supply chains. Back in the US, homeowners are using these systems to fight back against rising peak electricity prices. By combining solar panels with DIY batteries, families are shifting their energy use away from expensive peak hours. The financial results are real. Some households report saving hundreds of dollars a year, paying off the hardware in just months. These aren't laboratory projections. These are actual numbers shared by people who built the systems in their own basements. Despite this success, there's been no institutional response. No corporate endorsements, no government guidelines, just silence from the utilities. But the community doesn't mind. They aren't looking for validation. They are looking for solutions that actually work for regular people. Information continues to spread from person to person, forum to forum, carrying Dan's vision across the world. In the end, it's about more than just electricity. It's about the power of shared knowledge and the freedom of independence. Because when the world goes dark, the light we build ourselves is the one that shines the brightest. What if the solution to our energy needs was hidden in plain sight, sitting in scientific journals for decades, waiting to be rediscovered? This is the story of the aluminum air battery, a technology as abundant as the Earth itself, yet ignored by the modern market. Dan, a thoughtful local handyman, didn't invent the science, but he saw the potential that major corporations simply couldn't monetize. The design is deceptively simple. Aluminum sheets, salt water, and a few wires. No high-tech lab required, just a shed and some curiosity. Why hasn't a major company sold this to you? Because the components are too cheap. You can't build a business around the recycling bin. Markets excel at delivering monetizable products, but they often overlook solutions that are free or easily built from kitchen staples. Dan took this unprofitable knowledge and shared it at local halls and online forums, sparking a DIY energy revolution. In his shed, Dan refined a system that provides power when the grid fails, using materials most people throw away every day. This isn't about replacing the global power grid. It's about solving a specific human problem, the helplessness of sitting in a blackout. Imagine your food warming in a dead freezer while you wait weeks for a professional. That helplessness is now entirely optional. For just $22 in a single afternoon, anyone can build a power source that keeps the lights on when everything else goes dark. Across dozens of countries, neighbors are sharing napkin diagrams and video tutorials, building their own versions of Dan's design. The aluminum air battery represents a shift in mindset, from being a passive consumer to becoming an empowered, self-reliant creator. It's proof that the distance between a problem and a solution isn't always measured in dollars or years of research. Sometimes it's just the willingness to look at what's already available and ask, is this enough? For Dan, and for thousands like him, it was more than enough. The knowledge is out there now, and it's staying. Next time the power goes out, look for the one house on the block still glowing with light from a plastic tub. The science is simple. The materials are in your kitchen. The power is finally in your hands.